Hey everyone, I see the first few people trickling into the room. We're going to wait just a little while for more people to show up, and then we'll get started with this workshop. I'm seeing 25 people so far and counting. How's everyone doing? Assuming a lot of y'all are miners, how's Space Race going? We're almost halfway there. It's just kind of crazy to think about.
Can people post on chat where they're joining in from?
Seattle, lovely place. Oh, we'll maybe wait like just 20 more seconds and then get started. Very North America centric so far, but I suspect some people are being a little quiet. All right, we're 3 minutes past our start time. More people might trickle in, but for now we can get started. Hello, everyone. Thank you for joining this workshop. We are very excited to be presenting this, and I suspect a lot of y'all are very excited to be hearing this information. I know there's been a lot of demand to understand how some of our crypto economic decisions have been made, and really hoping that that we'll be providing a lot of clarity, a lot of insight into all of the decision making and work that has gone into this. For our miners, we're about a week and a half into Space Race, and I hope that's exciting for developers and other supporters of the community. We've never been closer to mainnet launch, and it's an exciting time in the Filecoin project. Today's workshop will be presented by ZX and Juan. ZX has been absolutely spearheading the crypto econ work for the Filecoin project. So there's no better person to be telling you how a lot of these decisions were made and kind of what the ideas behind them were. And Juan is hopefully a familiar face to all of you. He's the founder of the Filecoin project. So I will turn it over to them, and I hope everyone has a good time and has a lot of their questions answered. Juan will be kicking things off. So over to you, Juan.
Thank you very much, Ayush. Hopefully I can do justice to that great intro. So welcome everyone. This is what we think will be, the first of a number of workshops over time that we'll have about the Filecoin economy. We hope to kind of kick things off with some good discussion, and then just we hope to also have some continued discussion on Slack as we have been having for many weeks now. And then I hope that this one will be introductory. We'll kind of go through kind of the high level goals of the economy, why, and kind of cover various different sections. And then we'll go through kind of the report that we released recently in some detail. We will again, given the timing here, it's not like a 5-hour workshop. We only have 1 hour here. So we'll kind of go through each section to give you a good understanding at a high level. Then we'll go into a number of questions that we've received so far. So we put out a kind of a call for questions so that we could aggregate the most common questions and the most important questions and give more detailed answers on those. So we'll go through those questions. And then if there's time that we can maybe take some questions from chat. Definitely as we go through, ask questions as you have them. We probably won't answer them right away in the moment, but if you ask your questions, we'll be able to kind of touch on them as we either as we go or at the very end. And yeah, this is an experiment. We'll see how this workshop goes. If it's very useful and valuable for people, then we can do more over time and diving into certain areas to explain them in more detail. Great. So with that, I'll share my screen and go. Great. So this is like again a super high level intro. The thing to remember, and we kind of chose this diagram to emphasize it, is that we're in this period of time where we're creating these internet native systems and economies that you can think of as public utilities in a sense, but that are basically as large as cities or potentially even small nations. And those kinds of economies and systems are being run by people across the world. And these systems have a whole bunch of features that effectively make them full-on economic structures with many different kinds of participants that have different incentives, different goals, but that together are providing some service or some utility to the rest of the world. So one of the longstanding models that people have been using to describe these systems is to model them as kind of export economies. And so you can think of the whole system as a network with various different participants and different roles, and then using the token of the system to kind of transact within the system, and then having some kind of export structure to the rest of the world. And so you can think of the network, the Filecoin network, as kind of buying raw materials and kind of potentially importing raw materials, or potentially producing them at some levels, especially once you get into markets that are able to trade in Filecoin for buying drives and so on. But then for the most part, exporting the service out to the rest of the world of the cloud storage service. So it's kind of like the high level model. So we put out this report. We'll kind of go into it in a bit more detail later. I want to reference another talk that I've given in the past that kind of goes into detail on other parts of the protocol at different levels. And looks at it from a protocol perspective or from a blockchain perspective and so on. Today, we're going to be looking at it as kind of like the notion of the economy. So a couple of important data points for everyone to remember and kind of why Filecoin is here. We are in this phase transition as a species where billions of humans and trillions of computers now live and work together, and we're deeply integrated, and we are generating tons of data and computation constantly. And you can think of most of our lives now and most of our activity being assisted by computers in some way or another. The internet is constantly granting us new superpowers, and all of that comes in the form of applications that we're running. And those applications tend to, again, generate tons of data that needs to be stored and backed up somewhere. And beyond being stored somewhere, we want to have control and proper encryption and sharing controls over how that data is distributed and shared to other parties. So it has become an extremely important part of our species and our civilization to be able to have an internet native system for storing and safeguarding all this information. This is only going to accelerate and get more intense as many new forms of computation arrive. So things like augmented reality, virtual reality, brain machine interfaces, and so on. I'm sure that many folks saw the recent kind of demo of the Neuralink system like that. Systems like that are going to become more and more kind, and suddenly our interaction as humans with the computing medium is going to get higher and higher bandwidth, and more data that's highly sensitive that we need to have kind of individual control over is going to increase. So, the amount of data in the world is just increasing tremendously, and these are kind of rough projections made by various parties that kind of plotted in terms of numbers of zettabytes that we're getting into. All of these are of course super unclear. Looking at the past, we can roughly estimate and know the rough amount of data. Looking at the future is highly unpredictable, but we know that we're going to be generating an enormous amount of data, and so we want systems that are able to cope with that level of information. At the end of the day, like these are of course, I repeat this a lot, so I won't go into detail here, but the long-term goals is to build a decentralized, efficient, and robust foundation for humanity's information. And so that each of these words have a lot of the features of the protocol and the network and the economy relate to each one of these words. Decentralization is achieved by building an economic system with incentives for all kinds of different parties in different nations and so on. The efficiency, that the economy supports the efficiency by creating market structures that allow us to optimize and provide services at better and better cost. We can achieve robustness by enabling many different parties across the world to enter and not creating moats or centralized systems that prevent parties from entering and providing their services. And we can really make sure this is a proper foundation by at the end of the day providing a system that everyone can rely on and trust without having to trust any one individual party, where the system as a whole will continue going on and survive all kinds of events. So you can use it truly as a foundational system for application building, without having to trust in the continued good behavior of any one party. So yeah, that's kind of an important detail here as well is at the end of the day, the data that we're collecting and that we're storing in all these systems, it is about all kinds of applications. So certainly there's a lot of organizations with a lot of data they want to store, but ultimately the thing that's going to drive the most usage is going to be applications. And so having deep integrations between Filecoin and all kinds of applications is going to matter a lot. So you can think of the whole growing Filecoin ecosystem as building the storage services infrastructure of the next decade to be able to provide the storage facilities for all kinds of applications. And so this, the market economy that we're trying to create is one where we can provide, on the one side you have clients with all kinds of requests being able to use the storage services of storage providers. And so this is, you can start thinking of the different groups that are participating in the network. And we've roughly kind of formulated these 5 groups: clients, miners, developers, token holders, and ecosystem partners. We'll look at them in a little bit more detail later. I will flag here in the center part that we're in the middle of the space race. I think roughly we've hit 88 petabytes in around 9 days or so. I think in the last days we're kind of growing at around 10 petabytes a day, which is an enormous amount of storage. Like this truly tremendous storage growth rate. And if we're looking at it from a yearly perspective, if we can keep that up, we can really start hitting in the kind of like 3.5 exabyte range. So that would be truly phenomenal if we could do that. And just to kind of benchmark there, like that starts being kind of a significant player in the global scale of storage. Huge kudos and thanks to all the folks that are running blockchain explorers and all the participants in the space race. Really exciting. One of my favorite graphs here is just like how well distributed the storage power is across a lot of different folks. That's phenomenal. This is one of the best power distributions that I've seen in any blockchain, and like that's really phenomenal to see this level of decentralization. Great. So with that, let me switch over to the report, and then we'll dive in. You can see that, correct? The page. Sweet. So I kind of covered like the high level here. There's a lot of one of the key introductory points is like just how much data we're storing in the world, but and we chose like one simple graph to show that there's of course all kinds of other ways of segmenting this data, looking at different kinds of distributions that are coming from different kinds of applications and systems and so on. And also the amount of data growth in different geographies matters a lot to the network, or other kinds of systems like that. So at the end of the day, the Filecoin network must be able to adapt to the demand of storage and storage services around the world. But just kind of the scale here is a staggering amount. Six, I don't know if you want to add anything to that part. Otherwise, we can. Yeah, I guess one key point here is the combination of different features around Filecoin bringing together verifiable storage, where you can guarantee the correct storage of data in the long term. It's an extremely valuable and useful property that hasn't been around at this kind of scale before, and so we'll see what kinds of use cases and applications come from that. One important property is open participation, being able to having anybody be able to enter the network without having to know anybody else, and being able to join and provide storage power in the network and provide a storage service and so on. This will get, of course, easier and easier as things like the retrieval market and so on become part of the system. Right now, there's kind of like a high barrier of entry for people to be storage miners, but as we improve the proofs and as we get other kinds of mining, like retrieval mining, that barrier for participation is going to drop lower and lower and lower, and so that'll enable a whole host of other participants to join. One of the really key things here is that we try to design this whole system all over the place to really enable people to optimize locally for their regions, and so and to kind of be able to provide direct access to content and data directly from miner to participant. And so clients being able to select which miners to store data with in the geographies that they care about, in the regions that they care about, or with the kinds of facilities and so on that they care about, enables kind of an optimization in the marketplace that may not be possible in other networks and other designs. In one of the hopes and goals over time is that, of course, miners will specialize over time, and perhaps we might see that certain kinds of use cases will start preferring certain kinds of miners and so on. So we'll see how that develops over time. Maybe that'll happen over time and over the many years. CX, if you want to add anything, feel free to jump in. Otherwise, I'll keep going.
Yeah, I think it's important to highlight that it's like we're building the basic infrastructure to allow for other things to evolve and emerge, as long as everything is serving and contributing back to the same goal of the network, then we are achieving something very successful here.
Yeah, so once we start looking at the economic structure, at the highest level, we have to remember we are building a marketplace for data and for data storage and the data service. And so that, there's a few basic set of kind of commands or actions that the different parties take in order to be able to do that. A lot of you who have participated in the space race or have played around with testnets and so on are probably familiar with the idea of being able to propose deals, then miners being able to accept or reject deals, then clients being able to transfer the data directly to miners, which can happen online or offline. So you could, if the data is big enough, you could send it through offline means like packaging and so on. And then once the data arrives with miners then putting that data, the data for that deal into sectors, sealing those sectors so that they can become provable, prove that into the chain and start earning not only the deal rewards, but also the block reward from an increase in their power. And then later, of course, clients being able to retrieve the file. So right now, one important caveat here is because we don't have fast enough proofs to provide super fast retrieval straight from the sealed storage, which we hope to have in the future, because we're not there yet. We're in the mode right now where we're kind of spending more storage in order to provide really fast retrieval, and that's kind of a requirement now. And so the sealing amount, sealing the storage allows you to prove it to the network for kind of like the keeping an extra copy around that's unsealed allows the fast retrieval. Over time, that requirement we hope will go away as we get dramatically faster proofs of replication that allow unsealed data directly from the sealed storage. That's sort of the goal where we're headed. And we already covered a bit of kind of how to model the expert economy in general, but you can think of all these different parties that we talked about, the miners, the clients, the token holders, the developers, and the ecosystem participants as taking various different roles in the economy. And those larger segments are not uniform. You can think of storage miners and retrieval miners and other kinds of miners that might emerge in the future as providing specialized services. You can also think of developers as fulfilling various different kinds of roles, like developers of the protocol and researchers and so on, or developers of applications that are building ways to use the storage, right? So developers and participants that join the economy and are building applications that use the network will then strengthen the whole economy and will help everybody operate better. So one big part of this is to really think of this whole system as the whole economy. There's all kinds of competition, internal competition within different agents inside of the economy, but in a kind of a macro scale, the whole economy either works together, either succeeds together or fails together. And so that's a really important piece here, where you want incentive structures all over the place, where you have both a kind of the internal competition to be able to optimize and create a more efficient system, but you also want the larger macro structures that enable the entire community as a whole to succeed together.
Exactly, and it's not like, I think the mindset here is it's not zero sum. And I think like for us to create a very useful and a reliable network, people do need to come together and collaborate. And then part of the cornerstone of blockchain technology is it provides interesting way for us to coordinate and collaborate together as a species.
Great. So jumping into the participants in the economy, we've talked a bit about miners and clients, but let's talk about some of the others. So yeah, with developers, we can have protocol developers, application developers, tool developers, and service developers. So think of people being able to provide better systems and better tooling for miners and other storage providers, or potentially for clients. So imagine developers coming and creating something like a kind of like a marketplace UI where you can see all the different miners and their facilities, and you can see pictures of their setups, and they can kind of advertise other added services. So all of that would be extremely useful and valuable, a really useful and valuable addition to the network, and addition to the economy that will come from the developer group. Then the kind of the group of token holders, that's one of really key component to all of these systems, is parties being able to use the currency and be able to buy and sell tokens from all the other parties to help those parties offset their cost, right? So at the end of the day, clients, miners, developers, everybody has to eat, everyone has to pay for their raw materials and so on, and you need an economy that supports those kinds of trades and those kinds of systems. We also think that there might be all kinds of possibilities for the whole DeFi world to connect to Filecoin in a very interesting way, to provide things like loan structures and so on for parties seeking to participate in the economy, whether it's to finance things like larger setups, or maybe a new party wants to open a whole new miner and wants to raise capital in order to be able to do that. And so being able to do kind of loans through the DeFi ecosystem becomes a really valuable, useful thing, or potentially being able to do systems where people are buying and selling the actual raw materials directly with these tokens. And so, for example, being able to buy and sell disks or CPUs and GPUs and so on, all of the stuff that goes into actually providing the service, doing that with Filecoin and so on, will require a very thriving economy of token holders, as well, as we've seen with Ethereum and other systems. And then ecosystem partners are a key piece here, where this is kind of like a larger catch-all term for larger groups who are providing kind of some differentiated or unique service into the ecosystem, and are kind of you can think of Protocol Labs or the Filecoin Foundation, or even new and exciting groups that are joining, like many of the organizations that have been developing implementations or developing new services and so on, who kind of are participants in the economy and are taking certain kinds of actions that are supporting the growth of the system. So, for example, grant programs are a good example for the kind of thing that ecosystem partners might do. Or, for example, suppose that a very large manufacturer of storage, like think of like disk manufacturers like Seagate and Western Digital and so on, get involved in the network and are starting to participate directly with the network, then they would sort of become these high-level ecosystem partners. And so that's a really important role in the whole system for people to be able to participate in. I would think of kind of like the verifier network as part of that. Great. So let's move on to storage services on Filecoin. So we talked a little bit about kind of things from the high-level client miner operation, but looking at it a bit from the notion of the life cycle of a miner, let's look at a miner, a participant that wants to become a miner joins the network and first creates a miner actor through the blockchain. And so there's a set of operations that you run, and you can create a miner. From there, you need to commit capacity into the network, and the commitment of capacity requires a collateral, and that's so that once you start earning power in the network, if you don't provide the proper power in the network and with the reward that you're getting, you may need to be slashed, and so that's where that is coming from. We need a portion, an economic structure there, and a mechanism that allows the network to slash participants that are signing up to commit and store capacity, but actually don't do so. Once kind of enough capacity is reached to become kind of the minimum miner, at that point, a miner can start minting blocks and creating blocks. And at that point, they can start earning the block reward, which is one of the strongest incentives in the entire system. And so, being able to commit a lot of capacity, reach a certain threshold to become to mint blocks is a key part. Once you're there as a miner, you can continue adding capacity and potentially start stealing useful storage into that capacity. And so that's kind of when miners start making deals with users and with clients. And so clients and miners find each other, arrange for a deal to happen, transfer the data either online or offline, and then that data gets sealed into storage. So the clients at that point put up a collateral. And so when they do so, both the clients and the miners put up collaterals associated with that deal. If the miner fails to succeed in keeping around that deal, then that collateral is burned. If the client, there are certain conditions where a deal collateral on the client side is useful. We had other mechanisms that we're going to make use of it. Right now, we don't have a minimum at the moment, but there are all kinds of structures that might actually use that more effectively. And then, and for example, one of the key things here that is often a question is, what happens if somebody's trying to store something that miners don't want to store anymore? Can they get away? Can they get out of the deal? And so one of the goals in the long term is to be able to have a collateral to slash there for clients. That's not in place right now, but in the future we'll be able to have that kind of system. We expect that to come through a Filecoin improvement proposal. Then after that, you can think of kind of the full life cycle of a miner. Once they have a lot of capacity or sealed sectors with storage in there, miners need to prove the storage that's in there. And that, if for whatever reason they have a fault and don't submit the person in the right time or lose some of the storage, then a fault will happen. Miners will have a predetermined amount of time to be able to recover that fault, and then continue proving. Anything to add, Zax, or I'll jump into talking about sectors.
Oh, good.
Great. So kind of the base unit of storage in the entire Filecoin network is the sector, and the sector is a certain a predetermined amount of storage space. Right now, it's 32 gigabytes, 32 gigabytes and 64 gigabytes. This is tied closely to the proof of replication. So as the proof of replication changes, the sector size might change as well. So Filecoin supports having multiple sector sizes because of that. At the moment, we're only using those two. Right now, I believe it's more efficient to use the 32 gigabyte sector, but as the chain throughput gets saturated, then it'll become potentially more valuable to use the 64 gigabyte sectors. So we might see this period where at the beginning is a lot of 32 gigabyte sectors, eventually at some point transitioning over to 64 gigabyte sectors. And here you can sort of see how sector quality works. And so one of the important parts about a sector is that a sector is putting together either has no deals in it, so it's just capacity that's been committed, or might have some amount of deals with useful storage in there. And the deals themselves can carry a multiplier, and that multiplier is an important signal to be able to sort of increase the quality of the deal and therefore increase the quality of the sector. So when we think about the duration of times that the deals live for, and the quality of those deals and so on, we can use the quality of the deals themselves to then add up into the quality of the sector. And that way, that quality is what gives the kind of quality adjusted power. So you've probably seen that blockchain explorers and so on have raw byte power and quality adjusted power. And so the raw byte power is just the raw notion of bytes of storage. But like capacity storage is really useful, but it's not actually providing a service yet. It's good to have actual real storage in there. Now, there's this fundamental problem between granting an incentive for adding storage, where if you can't tell that that's actually useful, then you're potentially incentivizing the storage of garbage and the storage of zeros and so on. And that's not useful to the network, and that's actually really bad for the network in the long term. So this is where kind of like the whole verifier network and so on has to come in and participate. We'll touch on that a little bit later in the conversation. But that's sort of where this quality notion is coming from. The quality notion is coming from being able to look at the different quality of the deals and then add that up into a different quality of the sector. One important thing here is that this whole area could be subject to all kinds of improvement and research, right? So, for example, if we found a magical automated way of checking, raw data and check that it was, good and useful without having to need something like the verifier network, then maybe we could have a quality multiplier that applies that way directly to all kinds of regular deals. But that's kind of like a very hard open research problem that might take years to solve, or maybe never will be solved. There's maybe an impossibility result. But the point here is this kind of structure and framework enables the network to classify different kinds of qualities and quality multipliers for different kinds of deals in the long term. In the short term, we sort of expect only these three options: committed capacity, regular deals, and verified client deals. And they have these three parameters. Over time, if we can find a way of distinguishing between a regular deal and the garbage, then maybe that quality multiplier can go up, and maybe we don't need the verified client deal or something like that. Or maybe in the future, we might find that the quality is actually really useful as a mechanism, and we might end up with many other kind of categories of things in there. So we'll see how that changes over time. But for now, what you should think about is just there's raw byte power, and it's really useful to provide capacity to the network, but it's much more useful and valuable to provide useful storage. And to the extent that we can really enable all kinds of useful applications across the world, across geographies and across use cases and applications and so on, to get verified client deal quality, then that will be a very, very useful way to direct the Filecoin network to store really valuable data for all of humanity. And so that's kind of like the long-term goal. But for a while, we'll be fine with just amassing capacity for a while. So at the moment, Space Race has 88 petabytes of capacity. There's no useful storage in there yet. But once we kind of amass that capacity also in kind of a geographically redundant way and so on, we can then start gathering the sets of clients and so on that will come in and use all of that capacity. CX, anything to add?
Yeah, and I think part of the coverage here that we need to assign a deal quality for a sector is changing blockchain states is pretty hard. So we can't really keep track of a dynamic quality of a sector as deals in it expire, which we would love to. So as another pragmatic trade-off here, we assign quality to the sector and make sure that the sector quality doesn't change throughout its lifetime. That's why we see the weightage is on the space time occupied by the sector, not just space or time.
Yeah. Yeah, and one important piece at the end of the day is that miners are providing space time, right? You're providing a certain amount of storage space for a duration of time. So the actual unit that people should be thinking about is providing that space, the quality of the space time. And so as deals expire maybe less in a shorter time frame than the sector, then the quality of the sector might be might lower over time.
Exactly.
Oh, I went too far. Great. So let's talk about stealing sectors for a moment. So as we know, the proof of replication is kind of an expensive computational operation over raw data, and that's what enables the data of a sector to be able to be sealed into something we can actually prove in the network. That algorithm that we use to go from a raw unsealed sector into a sealed sector is the proof of replication. And right now we're using SDR, stacked depth robust graphs, stacked depth robust POREPs in order to be able to do this. Over time, the community has also seen the NSE POREP. That's another really great candidate. We've evaluated many POREP candidates over the last 2-3 years. We have designed tens of different POREPs. But ultimately, it's pretty tricky to get all of the optimizations right and get exactly the right function that will give us the right characteristics in both sealing cost, proof size into the chain, sealing and unsealing times, and so on, and also make sure that it's oriented towards commodity hardware and not ASICs and all that kind of stuff. So currently we are in SDR. We hope to upgrade to things like NSE in the future, and there might be even, like, we already know of potentially many better POREPs that would be much faster to operate in, and so we expect all of that kind of functionality will improve over time. Now, of course, those upgrades will usually come in the form of kind of this optional upgrade where, as we come up with a new, as the network and the whole community comes up with new algorithms, we can suggest them, review them, analyze them, security audit them, and test them. Once we're confident it's a good one, we can add it into the network through a Filecoin improvement proposal and add it as an option. So then some miners can start storing with that. And if that proves useful and valuable, then more miners will choose it. And so we hope that when we add the next upgrade, miners can still choose whether to store in SDR or store in or NSE or something else. So we think of like that kind of an evolutionary landscape or an upgrade landscape to be the right pathway where the systems as a whole will get better and faster as new and better POREP algorithms come out. And so you building in kind of that notion of being able to upgrade over time without having to lose anything there is important, right? So making those upgrades optional is important for miners because you want all of your SDR storage to continue being useful and valuable through an upgrade like that. And maybe one important thing there is you can think of the cost of sealing, the raw cost of sealing as a big expenditure for the Filecoin network, right? So all of the cost of the production of the whole network is going into the cost of sealing. So making sure that the sealing cost goes down over time from one algorithm to another is really, really valuable because that means that the whole economy is paying less for that same function. So this kind of research is extremely valuable and useful to the whole network. Anything to add, Zex?
Yes, 100%. And I think that goes back to the analogy of how can we make that conversion process from raw material into exportable services or goods more efficient and robust. And I think that will go a long way, both in terms of the proof upgrade and many other kinds of upgrade, including consensus, that will play a role in doing that.
Great. So let's dive into the life cycle of a sector. So when a sector is added to the network, and maybe I'll use this diagram here. So at the very beginning, the sector starts by a miner just unilaterally packing some amount of either just raw capacity or a set of deals and so on into a sector. And there's some amount of you can think of sort of the deal payments that the clients put up as being part of that, associated with that sector. So when that packing is done, then a miner seals the sector into a sealed sector. In order to do so, has to make some commitments into the chain and then do a proof. So there's a whole kind of flow for proving to the network how that the sector was sealed correctly. Once the sector has been proved correctly, then it joins part of the large amount of storage that the miner is providing, and that's where a proof of spacetime just checks over time that all of that storage is being stored correctly. And so miners in kind of a steady state are proving a large amount of storage all at once of all of these sealed sectors. Now, those individual sectors have expiration dates depending on when they were started and depending on the lifetime of that sector. And so that sector over time will potentially expire, which is the normal flow. And then at that point, after that sector expires, then all of that is garbage collected and that space can now be used for new sectors. Or potentially that sector may be terminated. So terminated is a case where miners might lose the data storage. And so there's that termination is really bad for the network. And so that comes with a high cost of slashing. So the good case is when sectors and the lifetime of the sector expires. Now, if a miner suffers faults or something like that, then those sectors might be terminated. Or potentially if there's some downtime in the large scale, those sectors might go into a faulty state for a while. And then there's kind of this recovery period to be able to recover that storage before they're fully terminated. And so here, there's a set of fees associated with these kinds of operations. So when there's some commitments put in place to be able to seal a sector, and then some amount of pledge collateral associated with having a sector in the network, that then enables you to start earning block rewards, which are pretty significant. But then if there are faults, then there are certain fees associated with that. There are fees for reporting a fault correctly, and so if miners have just an operational failure and they have kind of an honest mistake and kind of report a fault, then there's kind of a certain fee associated with that. If there is a fault but there's no kind of honest reporting, and then the chain has to catch it, then there's a higher fee for that. And then of course, if the sector ends up being terminated, then it's a much larger fee for losing all of the storage. At the end of the day, the whole Filecoin network should look at sector termination as a really bad event. If sector was terminated, it means that client's data was lost. And if client's data was lost, that's a really terrible situation. So imagine, if you go to the bank and you store money, or you go to any kind of any website that is storing your photos or messages and so on, and they lose the data. If that service loses the data or the bank loses your money, that's like really, really bad. So we should look at sector termination as that kind of an event. Miners are agreeing to store data in the long term, are earning a lot of block rewards for doing so. And like that's the valuable service that the storage miners are providing. If storage miners are not properly providing that service and fail for the network and fail for all the clients, then that termination fee that's why it's that pretty significant. Anything
this ties in, this ties in nicely with the space-time concept that we brought up earlier when we talk about sector. So when miners add a sector, it's a commitment in terms of space and time that they need to provide and maintain to the network and the clients. And the reward should go exactly to this reliable and useful storage. And if you terminate early, the sector storage is not very reliable and is not very useful. So therefore, the reward shouldn't go there.
Yep. All right. So miners have, in general, right now, storage miners have a few different collaterals. There's the pledge collateral, and then there's the storage seal collateral. And you can think of these collaterals the same way that you should think about proof of stake systems and proof of stake systems with collaterals. These are systems that enable the right mechanisms to incentivize correct participation in the protocol and the system. And so those collaterals are sized accordingly to provide good behavior in the whole system and to achieve like the good correct economic output. So at the end of the day, you have to look at a large system where parties are competing with each other, potentially working with each other or against each other, and so on, to try and provide this global service. And when that happens, you need certain kinds of structures to make sure that the economic activity is good and positive and is helping the whole network grow. And so that's where kind of the sizing of these collaterals comes from. The initial pledge collateral, for example, is early on we had a bit of a different design where there was a much larger upfront collateral, and we kind of heard a lot of feedback from the community saying, hey, what if we could use the block rewards as part of the collateral? And so kind of like the block rewards come in and become part of the collateral as opposed to just having to put up all that collateral upfront. And so we redesigned a lot of the system in order to satisfy that, where kind of like the requirement in the collateral is actually a lot smaller now, and just kind of covers like an initial period, and then the block rewards will then accrue as collateral for some period of time. That initial pledge has to satisfy a few things. So when the network is young and small, the collateral has to also help increase the attack costs into the system. So at the end of the day, the whole consensus protocol here relies on the storage power being working correctly and not having a 51% attack. And so when the network is kind of smaller and it's relatively cheap or easy to get enough storage to mount a consensus attack, then we need something like the pledge collateral to increase the cost of that attack. So you can think of this exactly the same as kind of how in proof of stake protocols, a consensus attacker would then have to buy up a lot of the tokens to mount that attack, and then and that makes the attack extremely expensive. You can think of that the same way here. Now that initial pledge collateral will decrease, that amount will decrease as the network gets larger. So if the network gets really large, then kind of the contribution of each particular sector to the whole network is actually much smaller. Therefore, the pledge collateral associated with that sector goes down. So you can think of at the beginning, in the early days of the network, because it's a lot smaller, each sector represents a much larger percentage of the total storage. So the pledge collateral is larger. As the network gets bigger, then that collateral goes down. Hopefully that helps explain some of the confusion around collateral. Sorry. Yeah. So then we also have a deal collateral associated with miners, where as part of entering into a deal, there's a certain amount of collateral that needs to be associated with that, because again, if the miner is creating, we want to disincentivize a couple of things. One is the creation of fake deals, and also making sure that those deals are correctly served. It's a very important market mechanism to enable clients to be able to sort miners by collateral. So we believe that clients are going to be selecting miners that offer larger deal collaterals, because the deal collateral is a statement from the miner betting that they can indeed store the data for longer periods of time. So as a client looking at the market and trying to hire storage providers, the client would select miners that offer a much higher deal collateral. That's why this is variable, to enable a market mechanism to find what the right value for the deal collateral is.
I think one thing I may want to add here is when people talk about collateral, really it's incurring a capital cost. Like sometimes we may think of it as like it's an upfront commitment, but really you still get that collateral back after the commitment is fulfilled. So really is a capital cost for a small period of time. It would be a conceptual mistake to think that the entire thing is the cost, or that say something about the expectation.
One important piece here is also to think about redundancy. So the whole system makes sure that any one participant in the network, any one miner that is storing data, has a very high cost to losing that data. But clients themselves have to account for the fact that might happen. And so clients need to be able to hire multiple miners in order to store their data. And so this could happen in a number of ways. So one way, the kind of straightforward, simple way, is to store multiple replicas of a piece of data. And that's okay. Another way is to use erasure coding, where when you really care about the long-term survival of the data, you have a client can take their data, erasure code it into a set of pieces, and kind of break it up into a lot of little pieces, and then sort each of those pieces with different miners. And that creates a level of redundancy and reliability that is extremely strong. But it's very expensive to be able to retrieve that and reconstitute the data. So there's this trade-off that is entirely available to clients to explore between creating full replicas of the data, like full individual copies of the data, and store them with different miners, or using erasure coding and breaking it up into individual pieces and storing each of those pieces with different miners. So all of that is available to clients.
I think this is a classic example of the protocol defining a very small subset of things that we want the incentive and rewards and penalty to hold true. And then everything else, we leave it to the ecosystem and the market to evolve and emerge. And this will be a perfect example of like how another marketplace of different features can just be built on top of that.
Another component here is being able to retrieve things quickly. So I covered earlier that for now we're doing fast retrieval by maintaining an additional copy. Over time, the fast retrieval will be able to happen over just a properly sealed copy once we get fast enough proofs of replication. But there are other kinds of retrieval that might be offered. So fast retrieval is not just about being able to sort the data quickly, but also a miner being close to the user. So that's where the entire retrieval market comes in. So a storage provider a storage miner might be located in one geography, or they might start participating as well as a retrieval miner and getting copies of the data in specific locations to be able to serve it very quickly. This is the trade-off between long-term storage and content delivery networks. And so we want miners in Filecoin to be able to select where they want to be in that continuum, whether they want to be just storage miners backing up data in the long term, or being able to serve it really quickly, closer and closer and closer to the user, and participating in all of the retrieval side of things. We'll cover the retrieval market a little bit more later. Great. So one important component here is the ability to do offline data transfer. So once you start trying to send terabytes of data in the network, you can't really send it over the internet very quickly because just most of the connectivity between computers is not that fast. The bandwidth is limited, the data speeds are limited, and so on. So and this is very common across large scale storage services. If people want to store lots of data, think of many terabytes or petabytes, at that point, we need to be able to ship the data in hard drives from client to miner. So one very important part of the whole system is that it needs to be able to work with offline data transfer. So clients are able to hire a miner, make a deal, then send the data in disks, in hard drives through the mail. And once they arrive, miners are able to take that data, check it's correct, and then add it to their sectors and seal it in. So it's a really kind of an unusual sort of requirement for an online blockchain protocol. But when you're dealing with data and we're dealing with storing large amounts of data, you encounter limits that just the internet can't satisfy. So we need to take the internet and move it into the mail. And so like you think of this as like the first one of the first systems where we're kind of integrating not just the internet data flow, but data flow over the packaging system.
And I find it super exciting. Like we'll find out another blockchain that does that. Oh wow, that's really cool.
So one of the important parts of all of this is that the amount of data that the whole network stores is kind of related to the utility that the economy provides, right? So you can think of the Filecoin economy as having a notion of utility or value provided to the world, and that utility increases as more useful and valuable data is stored by clients. So the whole network and the whole economy really wants to make sure that the clients have a great user experience, that have a really useful service, and therefore we want a market structure where clients have a lot of power, being able to kind of select the miners that they want to deal with and they want to prefer, being able to get strong assurances about the quality of the storage that they're getting, being able to count on the data being verifiable and provable, and so on, and so on. So we want so clients are kind of like really extremely critical to the entire operation of the network, and so we want to make sure that clients have a lot of power in being able to make deals and causing the right behaviors to happen. So the whole life cycle of clients is one where in order to they have initially some data they want to store in the network, and they find out about Filecoin, and the first thing they do is they want to hire a miner, and so they might start investigating what potential miners they want to store with, and so they have to be able to make they have to make a client account, and so they make an account in the network. They may get verified. We'll talk about this a little bit later, but they may go through this verification process. And then once they're trying to store data, they find the right miners and they go to the right, and they might do this through marketplaces or deal aggregators or similar. They find the miners they want to make a deal with, and then they go and make that deal and commit it into the chain and lock up a certain amount of money in that participation. So at that point, that money that the client provided is locked in the chain. It's not yet given to the miner, but it's locked in the chain over time. As the miner proves they have data storage, that money that the client locked is released to the miner over time. And then later, the client may retrieve the data at some point in time. It's worth noting here that the data in the internet, most of the data generated is never retrieved. It's basically stored once, and may or may not be retrieved in the future. Most of it is really important data that needs to exist, and only a small part of it might need to be retrieved. So think of all kinds of important archives and records and all of this kind of information is stored but potentially read only once or a few times. So we don't necessarily need to make all of that data accessible super quickly. What we need to make accessible really quickly is a much smaller amount of data that clients are going to request constantly. So a very small amount of the data on the internet is requested most of the time. So the vast majority of traffic on the internet is based on a small amount of the data that is stored in the network. So that kind of distribution has to be is part of this whole picture where at the end of the day, clients are storing their data and storing various different amounts. They might be replicating in different areas. They might be they might be hiring miners in different geographies to then be able to get the kind of geo-replication they want. And then once they have that in place, they might retrieve that data at different points in time. Can go into deal proposals in a moment, but anything to add about the lifecycle, CX?
No, just one last bit. I think like we verified client. I think we are really placing a lot of power in the hands of storage clients. They're not just going to sit back and relax. They're actually going to be an active participant in the economy, and how they participate, interact with the economy will drive the product offering, will drive like how the utility of the network. So I think it's super important to be cognizant of that, and we also come together as a common to put that into good use.
Great. So the deals that clients can make, and these are primarily storage client deals. There are other kinds of deals that maybe for retrieval market and so on. But here for storage deals, we're dealing with a few parameters. You can think of the amount that of data that the deal represents. You can think of the specific CID of the data that the deal is asking to store. Then there's an amount of Filecoin associated with that deal, and then there's other parameters like that might kind of, and there's kind of like a certain amount of time that the deal has to last for. So there's an expiration associated with that deal. Over time, we have thought about a bunch of different kinds of improvements to the whole protocol, including the ability to extend deals, migrate deals from one miner to another, enable miners to transfer deals themselves, being able to upgrade deals, so being able to substitute the data that a deal has. So a client might need to kind of upgrade the data inside of a deal, and so on. So all of that kind of stuff just is sort of improvements in the long term. For now, the deals are very simple. It's a certain, they identify a specific amount of storage stored for a specific amount of time for a specific price with a collateral associated with it. Great, so let's jump into verified clients. So verified clients, this is and I gave a talk about this a few weeks ago, and a lot of this is still getting developed and so on. But this is about making sure that clients that provide really useful, valuable data to the network and increase the utility of the network, that are going to attract more clients, that are going to bring a lot more business to the whole system, can do so effectively by making sure that their data is truly stored correctly and is stored well by the miners. And so this is where the verified client and quality amount comes in. So verified clients are give that deal quality multiplier, and so the idea there is to create a very strong lever for the clients that are verified to make that data extremely valuable to miners. And so we wanted the condition where if between storing capacity, more capacity, or a verified client deal, miners are always going for the verified client deal. And so that's a very important piece of the puzzle. Now, of course, we would love to be able to do it without the verification process, and we would love to be able to do it with just marking deals. But again, there's this hard incentives problem there where If you just give a reward for deals, then you're just incentivizing the storage of garbage. And we need to make sure that that is really actually useful storage. For that useful storage, then if the utility of the network increases over time, if Filecoin is storing more and more valuable data for more and more clients and businesses and users, and is growing as a useful service to the world, then that'll bring in a lot more business over time. So, and then the miners are going to make a lot more of a return. So a really critical thing here is that by enabling the market to provide a high quality service and attracting more and more clients, we're effectively, the network is effectively doing business development, attracting more clients, attracting more users, and bringing them into the network, and then gaining a much larger size of the market and a larger size of the business. And so you can also think of verified client deals as a mechanism for the miners and the client, as a mechanism for the miners and the network to give very attractive deal terms to large storage clients, so that they come and join the network. And once they come and join the network and start storing a lot of data with Filecoin, they help improve it, they make it better, and they attract other clients and so on. So think of it also as kind of like a whole business development part of the picture. So verified clients are a really key component of the economy to attract a lot of users and a lot of clients to the network. Anything else on this, EX?
I think a common concern there will potentially related to like abuse and so on and so forth. But I think like as long as the process is transparent, we have accountability, and then we start with like limited amount of trust, and that abuse can be greatly minimized. And the net effect is a very pragmatic approach to actually solve a very difficult technical problem.
Yeah, exactly. And so I think we'll write more and talk more about that whole verified client component, and we're working there to find like a really good open structure. We really want to make sure that verifiers are well distributed across geography, in different countries. We want to make sure that they are have a lot of familiarity with different use cases, so different kinds of data storage, so consumer data or business data or scientific data, all of that kind of areas well covered. And we want to make sure that there's like good redundancy of verifiers. So if one verifier is not working super correctly, people can go to another. So there's a whole kind of whole network associated with this, and we'll be writing more about this process. And yeah, if people are interested in being verifiers, definitely reach out. As Yex said at the beginning, we're gonna start with a smaller number, and over time kind of grow that. And it's a really important function for the entire network to help make sure that we're storing really high quality and useful and valuable data, right? So if verifiers are not doing their work correctly and are allowing garbage to be stored, then that would be really, really bad for the economy long term. It might seem like it's good for miners at the beginning, but it's really not. It's going to not be a useful incentive for the long term. It's not going to attract better users. It's not going to attract more business and so on. So it's kind of like a short-term oriented thing versus long-term oriented thing. Great, let's go to content delivery. So this is the part where we talk about sort of the retrieval mining. So one really important part of the whole network is being able to store and retrieve the data. So you want to not only store it, but serve it really quickly. And this is where we start looking at not just the storage services, but start looking at kind of CDN style delivery networks. And this is where what we really want is a network that fluidly kind of adapts to the demand of clients trying to retrieve data. So we want a very rich and successful retrieval market where miners that are serving data to users can do so as quickly as possible and for cheaper and cheaper prices. And so the content delivery flow as it works now is that clients need to find which miners are storing the content and then retrieve the content directly from that miner. Over time, as we add more and more facilities to the retrieval market side, and this is entirely off-chain, you can think of this as all layer 2 solutions. This can happen with more and more interesting components. You can think of being able to have gossip-oriented protocols that find different pieces of the different pieces that are stored and advertised in the network, and then being able to kind of serve to the user really quickly. So we want to have a whole ecosystem here of different approaches and different systems that can provide retrieval, and at the end of the day, optimize the content delivery to work like really high quality CDNs. There was a retrieval market a summit a couple weeks ago, and we'll link it in the description of this video, so you can also dive deep into where that is at the moment and the flows there.
And some basic work, and some I want to highlight to to the audience that some part of this can be done today on the protocol, and for sure we can do. There's a list of features that will be available at network launch. Like we don't have to wait till like a much like later iteration of the protocol to enable this. Solve that it's here today, even though it may not be very smooth and so on and so forth, but like it's there and it's possible, and different like teams and companies can be developed just on this retrieval market itself.
Yeah, so one of the key of this is that it's entirely layer 2, right? So it doesn't require any hooks into the chain. We already have all the facilities we want, which are we know what the content is, and we have payment channels.
Exactly, and there might be ways to index and look for the content too.
And again, like here we have a diagram that is kind of geographically distributed. That's the kind of thing that we want and we need for a good CDN. We want the data storage to be well distributed around the world and to match the demand. And so, for example, if there's really high demand in one region, so suppose that, I don't know, maybe Shanghai suddenly has a large spike in Filecoin usage and a lot of people start storing and retrieving data in Shanghai, then we want a lot we want the retrieval market to kind of adapt to that, and suddenly a lot more retrieval miners appear in that region and provide and serve the data quickly. So we want that kind of adaptive CDN mechanism. And so there's a whole range of tools that can help support this, and is entirely layer 2. We don't have to do this through Filecoin improvement proposals, which means that we expect a lot of different teams to come up with many different strategies. There's a number of good projects and protocols that were coming out of HackFS that approach this in a couple of different ways. There's two or three. Around three different approaches to doing this over Gossip Sub that people are experimenting with. So we expect that this is going to be a pretty rich area for a lot of miners to participate in, but that'll come with time. Great. Let's go into demand and supply of the token. Great. So one of the probably most important improvements that we've made in the last couple of years to the whole economy is a really important change in the distribution and minting of the network of the token. And so this relates to the block reward and how the block reward is distributed. So most blockchains start with like an exponential minting approach, and that exponential minting just comes from Bitcoin, and it's pretty much what everybody sort of started following. Now a few groups started exploring with different things. So Ethereum famously changed that and then started doing a different kind of minting with a certain kind of fixed amount, which is it was kind of labeled as inflationary at the time, but it was kind of deflationary anyway, because it was the certain constant was decreasing over time. Or sorry, the constant was the same, but the proportion was decreasing over a long period of time. So as we explored whole different designs in the Filecoin economy, we realized a very important problem, which is the growth of the network and the utility of the network needs to, which we're trying to subsidize with a token, will come over long periods of time, but will not all come at the very beginning. Or said another way, what we really need is to be able to tie the success of the economy to the minting rate. So you want the minting rate to relate to the success of the economy. So this is where the network baseline comes from. What the network baseline is trying to achieve is to say that there's an ideal goal of the amount of storage that the network should be providing. If we're under that goal, then we mint less. And so we need to work together to reach that goal. Once we're past that goal, then that returns to normal exponential minting. And so that enables the creation of a very strong incentive mechanism for the network as a whole to work together to reach that network baseline, and kind of pushes off the competition for the block reward until kind of passing that baseline. And so this is, we think, is like one of the probably most important improvements that we've made to the economic design of the whole system. And we think it's gonna greatly reward the miners that are long-term oriented, that are providing really high quality services, and that are here for the long term. Now, of course, that's gonna not reward miners that are for the short term, that are just trying to like mine some tokens and leave and not actually provide useful quality of service. And so it's that important mechanism that creates a difference between the parties that are here for the long term and the parties that are not. If people are aligned with creating a really useful and high quality and high value service in the long term, then the network baseline is going to benefit them significantly, and it's going to make sure that a lot of the supply is released according to the amount of storage that the network is able to provide. If we can hit the baseline right away and maintain it, awesome, that's a great result. But what we don't want is a network to subsidize a much smaller network that doesn't reach the baseline. Anything else to add there, CX?
No, this is great. I think there are other small pragmatic things that we also do combine with baseline, which we will go into details in the FAQs. Yeah.
Maybe what I'll do is I'll zoom in a little bit on this image, because I think it's a really good, useful one. So you can think of this image as a really good way to describing different stages of the economy. At the very beginning, what we want is to build a lot of capacity. We want to optimize the entire system. We want to we want to arrive with really strong and secure proofs, but it's okay if they're not well optimized for retrieval. We want to have like basic retrieval in the protocol. And then we want a lot of and so in order to support all of this, then a lot of the revenue of miners is going to come from simple minting. As we reach stage 2 of the network, we want a drastically more scalable chain. We want a greatly reduced cost for sealing and for all operations. We want much more efficient proofs and retrieval. And at that point, we're starting to see, we want to see kind of the quality of service of the data storage and the retrieval to be much higher. And that means that suddenly deal payments become a stronger part of the revenue for miners. And at that point, we now should be hitting the baseline. And at that point, kind of the revenue of miners is coming from baseline minting and simple minting. And kind of as we, and so you can think of the baseline minting there as being a really key part of achieving that high quality of storage and so on. And kind of like the level of scale that we want, the level of scale of storage that the network wants. Once we reach stage 3, then at that point, the whole network can establish a very strong kind of brand and reputation as a storage system, can have a much larger suite of services and products, can be in many markets and so on, can have like really high quality CDN style retrieval. And at that point, kind of like the deal payments, the quality of service should be excellent and be able to compete with any other storage network in the world and be ideally the best. And at that point, it's the deal payment is going to be a large fraction, potentially dominate the revenue of miners. So it's these stages that the baseline is helping to achieve. The baseline optimization allows us to start with a lower stage where we're mostly building capacity and we're not setting. We don't know how much storage there's going to be. The quality of service could be lower, the efficiency could be lower, and so on. Then move into the stage 2 where we're optimizing very aggressively, reaching the right level of scale, reaching a much better and higher quality and much more efficient system, and then transition to a world where the quality of service is world-class, it's the best, and then we're able to deal with then the economy is thriving so well and is being so successful that the client payments flowing into the economy is what's the main source of revenue. So this is how we translate these stages. You can think of these stages as the stages of the economy. Stage 1 is early, the economy is at the nascent. A lot of people are coming and there's a lot of promise in the future. And so we're kind of subsidizing and bankrolling the entire effort. The block reward is paying for miners to come and join the economy. Then in stage 2, we're talking about optimizing and scaling the system, a thriving economy that starts providing really high quality, but it's maybe not the best in the world yet. And then in stage 3, we want to be the best in the world and source the vast majority of revenue coming in from deal payment.
And baselines, just want to highlight one more thing. I think baselines still reward early miners. Like early miners still has an advantage, except that it may not be an exponential advantage as it was before. But now it's really about the storage that is being on, and then the utility of the network. And I think the end goal here, I think, which is what we're trying to say here. Mining should still be profitable, and the economy should still be operating in a thriving and robust way, even when some of this reward subsidy starts to dry out.
Yeah, and so the amount of time here is variable. It really depends on the quality of service and the scale of the network. But we think of this as taking many years. You can think of of a system like Bitcoin or Ethereum. It's been many years in the improvement and quality of the service. So it may take multiple years to kind of make it through each of these stages. And these stages are kind of entirely about the quality of the service as a whole.
And it's in the hands of all of us here to determine how long the timescale would be.
Yeah, exactly. It's at the end of the day, this is our best guess. This is our all the work that we've put into this is our best guess into the structure. At the end of the day, this is a decentralized network, and it's up to us all together as a community to make this work, to really put in the work to create something of great value that builds a really great network that clients want to use and want to use for their applications, want to use for the storage of their data, and so on. So think of if you step back for a moment and you think of like what are the most successful blockchain systems in the world, and they're the ones that provide the highest quality of service. You can think of Bitcoin as the first one that provided the ability to move around money in the world in a very reliable and robust way, and it's one of the the most valuable blockchain so far. Ethereum is the second by and many would argue the whole economy on top of Ethereum and all of that put together is much more valuable than Bitcoin. All of that put together is coming from the high quality of the utility of Ethereum as an application platform and all of these other systems and economies that are built around it. So we want Filecoin to be an extremely valuable system and an extremely valuable blockchain, and that'll come from the quality of service of the whole system. We have to work together as a whole community to make that quality extremely good, extremely efficient, and great for the users. Great. Let's keep moving. So token allocation. So I think two really important updates here that are part of the protocol. So one is the amount of allocation for miners was around 70% of the whole allocation of tokens on Filecoin, and we were for a long time discussing and debating how much should go to storage miners, retrieval miners, and other types of miners in the long term. We had a lot of discussions with a lot of folks around what is the right amount in the long term, and we think like the subsidy of the network is most important earlier on, and it's most important earlier on for storage miners that are providing the large capacity of the network. So we try to give as much as we could to storage miners, and there's a strong argument that would say, hey, really, a lot of this should be going to retrieval miners, or a lot of this should be going to other kinds of miners like repair miners and others that might appear in the future. But we think that if we can create a lot of value in the next 2 or 3 years and make it an extremely successful and high value network, that then this large amount of the subsidy going to storage miners for the service of both maintaining the blockchain and doing consensus plus storing all of the data, those two services are worth this kind of minting rate. And so we'll see if that turns out to be the case. This is pretty aggressive and a lot, and so I think maybe the retrieval miners in the future that are watching this are going to be angry at me for presenting a so generous thing for storage miners and not for retrieval miners. But this is our best guess today. We think that this is the right allocation. We think that this reserves a lot for retrieval miners and other types of miners in the future. We hope it's good enough. But at the end of the day, this is going to be a 3 years from now, the network can look at the distribution and the allocations of what's remaining unminted, and if the community thinks that it should be apportioned differently, then that can be that is a community decision in the long term in the future. We think this is the right thing, but that's up to the community to decide long term. There's also a whole set of parameters here around different. So this table includes a lot of a couple important details. One is there's a lot of different variables associated with the token supplies. One important one is there's a number of funds that are burnt because they're part of collaterals that need to be slashed, or they're part of fees as part of the network transaction fee, and kind of gas being burnt and so on. That is going into the total burnt funds, and that's kind of burnt forever. The other important detail is market cap. So one important thing to note is there's a lot of different ways to try and estimate kind of like the value of cryptocurrencies and so on. We think our position is that most of them are pretty flawed. All of them should be taken with huge grains of salt. No one should really kind of take a look at those numbers and just kind of believe them outright. Most of them are very complex markets with order books that are not kind of infinitely large and so on. So you have to be really careful when you kind of try and estimate the value of the whole network. We feel a lot more comfortable about estimating the value of the utility of the network, like how useful is it, how much value is it giving to the world. But in terms of kind of thinking about a market cap and so on, that's we want to tell the community to exercise a lot of caution when trying to estimate the value of the network that way. We've seen some groups using some extremely aggressive and inflated numbers, like just using the total supply ever and saying that that's the market cap. That we think that is totally wrong and totally inflating the value and really, really off, and kind of it's kind of dangerous to do that. So please don't do that. We think that the most sober amount, the most kind of correct amount, is to use the circulating supply, and then that's like the right market cap size. But that's a suggestion. We're not the best. We don't make decisions for other people. People should exercise caution with how they make their calculations. But we think that the most accurate measure is to kind of use a circulating supply. In general, we think that the whole exercise and effort of valuing networks and so on is in its infancy, and we think a lot of that will grow and improve over time, and people will make much better guesses as to how to properly value these things and so on. Here are some initial parameter recommendations that kind of section 7 is about a whole bunch of other details that are part of the network, part of the protocol and a bunch of different mechanisms. And so these are kind of the initial network parameters that we recommend. These are not final. We're still refining some of them, and so we'll likely have an update to these coming in the next weeks. And we also expect the community as a whole to tune these over time. So we expect that this will be we'll have some strong initial parameters, but over time, as the network upgrades, as many new features come online, as the chain becomes more scalable, as we get new proofs of replication, these parameters will change and adjust with time. And that is entirely a community governance question, similar to kind of Ethereum improvement proposals. Filecoin improvement proposals will kind of drive adjustments to these parameters. And we expect a lot of the community to participate in making those really difficult long-term decisions. Anything to add, Zix?
Oh, sounds good. Maybe it's time for us to do some FAQs, or?
Yeah, sounds good. So let's move to your deck.
Cool. Let me share my screen. Well, thank you, Juan, for walking us through the report. I hope audiences understand better like the intention and why we design things a certain way. And I think I want to just reiterate on the goal of the system and one of the many mental models that we use to think about the Filecoin economy. We are all here together as a community to make to produce valuable storage-related goods and services and export that to the outside world. And we have a list of like common questions about the report that we collected in the last week, and I'll be happy to address some of these like one by one here. So for the first one, how does baseline minting? I think what they're asking is exactly work. There are different interpretations around of like how it works. So I hope we can provide greater details here. So taking a step back, I think we went through the goal just now with Juan. The minting rate should really tie to the rate of the network utility rate in terms of how valuable the network is in providing the goods and services. And we really want to incentivize and reward storage, not just stealing speed and hardware, even though they are important, but maybe not more important in an exponential way. And we also want to provide certain counter pressure to shocks. In the event that there's a shock event happen, there's this anti-fragile element in the system to bring people back and contribute back to the and ensure the running of the network. And therefore, we propose this hybrid minting structure in terms of the Filecoin storage mining allocation with 30% in simple exponential decay and the remaining 70% in baseline minting. And then we talk about what the baseline is, which is some kind of a network level KPI, which is like, this is an ideal case, how fast the network will grow, starting at what initial value. And then we define a progress of how all of us as a community in achieving this KPI, which is what we call the network time. And this is in contrast with in simple exponential decay, we have this notion of the simple time or the wall clock time that would always advance. And then we mean rewards based on the progress of the network, how far the network has achieved in terms of the space-time, that we expect. And as Juan mentioned earlier, if the baseline is consistently met, then the minting would be exactly the same with the original simple exponential decay. Otherwise, some early rewards are delayed and the minting rate will be spread out into the future. So on the right here, we have the mathematical specification. And here is just an example of what the improved minting rate would be. So as you can see, the initial minting rate is still high, still sizable, but we actually delay some of this min rate towards the future when, let's say, there's new improvement to the protocol, and now we can unlock greater potential. We can actually unlock a greater proportion of the KPI in a later date, and then we provide greater incentive. Juan.
Yeah, one important thing here, like that example improved mint rate is again just one possible example that depends entirely on the amount of storage in the network. So if we hit the baseline, amount, then it goes back to the original mint rate, right? So if we hit the baseline, then it goes back to the mint rate. If we are lower than the baseline, then we're deferring some of that currency to subsidize in the future.
Yes, and this is just one example, and how you actually, and the exact realization is still in the hands of the community. Cool, next, how is...
Yeah, sorry, one important detail here is like this baseline construction really gives a very strong, that strong sense of like deferring the strong computation until past the baseline is an important feature to make sure that miners in the early days aren't kind of like just measured in terms of their results against each other, but they're measured also in the results against the baseline. So everyone is sort of working together to reach that. Once we're past that, then miners start competing with each other in the way that kind of Bitcoin and other networks work.
Right. In the way that Bitcoin and other networks work, but they also compete with each other when we are below the baseline as well. So it's like a compete and collaborate relationship for all the miners. Yeah. And one thing to call out here too, I think there is a very subtle incentive for a sector of longer promise duration, because something that we realize is as new sectors get added, some old sector might be expiring. So it's actually in the best interest for miners to commit sectors of longer lifetime. But miners can make the decision for themselves. Cool. Next is how is initial pledge exactly calculated? So I think, so let's revisit revisit all the goals and constraints. It's not meant to be a barrier of entry for small miners. It must be small enough to be feasible for miners to join the network, or it's easy to reason about whether they should join the network. And it must be large enough to secure the network and provide an incentive to improve the quality of service. So therefore, there are two components that Juan touched on earlier. One is the initial storage pledge, which is based on the expected reward that the sector will earn in the future. And this provides some initial collateral for slashing against like penalties when before the sector earns any reward. And there's also the component which is called the initial consensus pledge. So the initial storage pledge is based on the block reward. And as block reward goes down over time, as a general trend, it may not be enough to provide sufficient guarantee to cause a consensus attacks. At the same time, it's also not proportional to the storage that you add. So in an absolute term, in a sense that if, let's say, the network has a lot of storage showing up, the total pledge doesn't change when the network has much smaller amount of storage showing up. So we want it to be proportional to the storage committed, and we also want to make consensus attack costly. So therefore, these two components, they are combined in this particular way. And the initial recommendation for initial storage pledge is estimated 20 days worth of block reward that will be earned by the sector. So if the sector has to be around for 180 days, it feels like 20 days of block reward initial pledge seems to be a reasonable number in terms of the token. And then the initial consensus pledge, I understand there's a confusion here about the 30%. And I think Juan mentioned earlier, it's a fraction that will help the whole network achieve that try to achieve that target when we are at the baseline or above the baseline. But in reality, for a particular sector, it should just be a very small amount of Filecoin. And that specific relationship is defined in the equation at the bottom. Anything to add on?
Yeah, I think, that's really well explained. I think maybe one other component in the long term, kind of like maybe years in the long term, people may want to revisit these calculations, in that you might find as we reach much higher scalability and throughput in the chain, as we do sharding and regions and all that kind of stuff, we might end up in a world where these equations need to be revisited. There's also a question around just kind of how much we'll find out over time as sector sizes change or sector qualities change and so on, whether that landscape of features changing might end up including changes to initial pledge. So we would expect in the long term, say 5 years out, 5-10 years out, to see changes here from the community. And that is the kind of thing that over time will, as a whole group, will see what is the highest likelihood of success for the network as a whole. At the end of the day, it's about making sure the network is secure, that we don't have any kind of consensus problem, and that the storage is well kept for the entire duration, and that's not at all going to be lead to bad incentives and bad incentive structures. And we also want to make sure that there's strong reason for parties that are providing storage in the network to be actively using putting their resources to work in the network.
Yep. And exactly. So I think it has become a common theme in our presentation today. Like it's an evolving system, and many of you have new discovery and new findings along the way. And I think as long as there's a better analysis that also respect the same constraint and making sure all these subsystems work together, we're happy to look at it. We can review the proposal together as a community and make decision from there. The next question, which also happened to be asked in the chat room, is what is sector quality adjusted power, or sector QAP in the previous slide? As motivated earlier, we want to reward sectors of different content slightly differently depending on what's inside the sector. And we also have the constraint that we can't really change this. We can't really change this reward percentage all the time. As sector expire, come and go, there will be a lot of changes to the blockchain state. So therefore, we invented this notion of a sector quality and also the multiplier to reward different sectors of different content differently. And the deal weight here is basically the space-time occupied by a deal type in a sector, and a sector is defined by its promised duration and its size. And then basically it would be the deal quality multiplier of the deal types in a sector weighted by the space-time. So we have like two examples here of how the calculation is broken down. So the first one, when we have like half of the sector is filled with verified client deals. And so we have 16 multiplied by 10, and then 16, which is the committed capacity deal type divided by the space-time of the sector, which would give us 5.5 for the sector quality. And there's another example down here. And this sector quality, which get converted into sector quality adjusted power, is also the consensus power in the system. Great, next. Let's see. This is a very common question. How can I become a verifier or verified client? So right now, I think the process is still under development, but we can talk briefly about the principles. And I think Juan mentioned some of that earlier. The verification process should be easy and plentiful. And the verified clients are intended to improve the utility and product offering of the network. They have a much stronger lever, and they also play a very important role, especially in early days, in shaping what the network has to offer and what the network is about. And it should also make the network more decentralized by adding a layer of social trust on a purely resource-driven network. And as mentioned earlier, with limited trust, transparency, and accountability, we can minimize the abuse of this mechanism.
I'll add here that this is one of the things that we need to describe and write a lot more about. And a lot of this program is still in development. The principles of CX are totally spot on. And some of the things that we're thinking about, and we're thinking about this not just in the Filecoin team, but with a lot of other participants that are starting to get involved in shaping the network and shaping the ecosystem, is to really make sure that there is good geographical diversity, good use case diversity, that we're looking at many different kinds of application use cases and use case domains, that we have multiple organizations, that we have organizations tuned to different sizes, verifiers that verify for small amounts of data, like say a gigabyte or 2 gigabytes or something, look very different from verifiers that verify for petabytes. And so all of those are factored in. At the end of the day, all of this is a community-oriented governance process similar to the Filecoin improvement proposals. So we're going to end up with some mechanism where there's kind of a community-oriented application process and a community-oriented review and approval of verifiers. So you can think of that as kind of like some of the principles. Over time, we think we're going to start with a network in kind of like a smaller size, and over time grow. So we don't want to immediately jump to having like 50 verifiers or something like that, because we don't yet know for sure how the entire system is going to work. So we think starting with something like 10 or maybe 15 or something like that is the right amount early on, and over time scale it out and grow it as we understand how the shape of the systems have to work. So we might go for, say, at the beginning, kind of geographic diversity, maybe 1 or 2 verifiers in different in various continents, and then over time scale it out to more and more parties. But it really depends on how these things work, on how the network operates and so on. But again, we don't need this to be in effect from day one. This can land and develop over time.
Yep. Next, so we mentioned a bit about the daily block reward and use that to calculate fees and also initial pledge. So then the question is, how exactly is estimated? So the detail here is the block reward per day is, from the first principle, is the likelihood for a sector mining a block and multiplied by the size of the block reward. And the likelihood of mining a block is dependent on it's weighted by the network quality adjusted power, and both in terms of its what it is and the rate of which that is changing. And the size of block reward is also recorded on chain, which is network reward per epoch. And we use both of these values are smooth on chain, and then we're making extrapolation to estimate how much a sector would earn in a day, and that will give us a much more accurate estimation than some of the earlier iterations. Next, how is minimum deal collateral calculated? This is in a similar calculation to the initial consensus pledge. So the reason why we have this in the first place is we want to provide some minimum level of SLA for storage clients when they enter into deals. And also, like, collateral also reflect the fact that deals consume on-chain resources, and this would be an extra additional cost to self-dealing. And I just want to call out, this is deal specific, so it's separate from pledge, which is per sector. And miners don't really have to, even though we don't encourage miners not taking deals, but like this is not incurred when miners are not engaging in storage deals. And the calculation is similar to what we suggest the equation before, 5% of the circulating supply, and then normalized by the network baseline, which will amount to a pretty small amount per deal per sector. Next, how does block reward vesting work? So we use the block reward to reduce, as collateral to reduce the initial pledge requirement, even though there is still some initial pledge. And the reward earned by the sector is still subject to slashing until its promise is fulfilled, which is in terms of both the space and the time. And reward vesting, it's sublinear to provide this strong incentive for miners to maintain their promise towards the end of the sector's lifetime. And one of the many proposals that we consider, and the one that we're recommending at the moment, is we have a reward delay, and then linear. So when a block is mined, the block reward is earned. There's a linear. So the block reward gets into the miner account, not exactly earned yet because we still need to fulfill other promises. And then there's an initial reward delay period, and then there's a linear vesting period. Okay. Oh, this is the common question I saw a few times in the chat room. Do miners need to purchase tokens for initial pledge? Well, the short answer is a miner needs to acquire tokens for initial pledge. It can come from many places: exchanges, lending, space race. There are many use cases that are being developed about lending at the moment. And I just want to call out, I think a lot of this anxiety that that sometimes we may have is with the network initialization. And I think it's a separate problem from the design principles and the rationale. And there are also other work streams to explore ways to make the initial onboarding smoother for storage miners. Juan, anything?
I should add here, yeah, I'll add a couple things here. One of the things we're exploring right now is how to use the sectors and the storage that miners have already added to space race in the mainnet. So now we can't guarantee that we're going to be able to do that, but that's something that we are exploring. So an important thing and takeaway from miners right now is, hey, you've spent a lot of time and effort in the space race and getting all of these sectors online. We're looking at ways to make sure that power we can start the mainnet with that power. So hang on to those sectors, and that might help solve this initialization problem, where we can start with a pretty sizable network, and then miners could just kind of sit there at that amount, and then just you don't have to add more until we start getting some of the block rewards and whatnot. So that's also available to you. You can just wait. Another option is like you don't have to buy anything; you can just wait. And so that's one of the things that we're hoping to add in. So this is a really important question. We're very sensitive to it. We want to make sure that the entire economic flow of the system works. Part of the space race goal was to enable the initialization of the network and being able to provide some initial Filecoin to miners to be able to actually use in running the network. And so yeah, look out for these options. And then yeah, at the end of the day, lending, exchanges, and so on, we think are going to be a big part of this. Once Filecoin and Ethereum bridges work better, we expect that a lot of DeFi constructions will probably also exist that enable miners to kind of get borrow Filecoin to be able to use in collateral and whatnot.
Great. The next question is, what happens if price goes down after miners purchase token for initial pledge, which is a question that we also we also see a lot in the chat room. So rather, we don't control price or can't predict it. and prices are a result of collective belief and action of all participants in the economy, in the market. And it's also meaningless to consider prices without looking at the time frame that you're talking about. Are you talking the next day, 3 months out, 6 months out? And it's just not a very meaningful discussion. And all participants in the economy will make the decision based on their own horizon and their own expectations, which is what I mentioned earlier. You could also wait.
Yeah, I think one important thing here is like all of these economies and markets are large, complex systems with many participants. The best advice is like, if you're not sure about your own things, don't participate. Like just hold back, just wait. Wait until the network advances and things stabilize. We want the entire network to exercise a lot of caution and be careful about the participation. We're trying to create good and useful ways for parties to enter the network through things like space race and so on. But we also know that there's a lot of miners and a lot of participants that have formed companies and are building organizations that are waiting for Filecoin to be live, that are burning a lot of money right now. And so we know that all of those folks want the network to arrive sooner, and all that kind of stuff, all that kind of thing. At the end of the day, exercise caution, make your own best decisions, be careful, and just wait. If you're uncertain about anything, just wait and don't make any rash decisions.
All right, next is a bit more back to the technical, which is what would trigger slashing and how does it work? So there are many different kinds of slashing, but I just want to focus on those related to the storage reliability. So when a sector is in a faulty state, a miner pays a sector fault fee for every day that the sector is in that state. And the rationale for setting the number is once reliability exceeds a reasonable threshold, the risk posed by this fee should decrease pretty rapidly. So if your storage is reliable, this shouldn't be something there will be a huge concern. And the second fee would be, so we want to incentivize miners for reporting their faults as early as they can and be. So if a miner does not announce the faulty state and instead the network detects that, and then there will be a separate fee in case of potential malicious or dishonest behavior, given that it's still permissionless network. And if the sector is in a faulty state for too long, then the sector is considered terminated, and the miner may have to pay a termination fee. On the other hand, a miner can also choose to terminate the sector themselves, but then they will also have to pay the same fee and also provide a due collateral if the sector that the miner terminates contain any deals. And there are also other fees related to slashing that disencourage malicious behavior, but they are not related to storage reliability. We can cover that if there's interest in some of those topics. Next, storage clients compensated in the event of data loss, and how will token volatility impact storage clients. So storage clients are not directly compensated for each lost file, even though the unpaid due payment will go back to the client. Part of the reason here is we are in a semi-pseudo-anonymous network, and the protocol has no direct way of telling whether distinguishing between like clients and miners. However, miners do have a very strong incentive to maintain all the storage on the network, and even stronger incentive for client data. And if clients choose miners with higher due collateral, they can also choose miners with higher due collateral if they are concerned with the incentive provided by the protocol is not sufficient enough. And just to answer the second part of the question, in principle, clients' exposure to price volatility ends when they enter into storage contract with the miner, as they transfer a token from a different currency into Filecoin, and the Filecoin get locked into storage contracts, and technically their exposure to the volatility has ended. And so then given all this slashing and penalty, what happens to the burned Filecoin? Right now, when they're burned, they are sent to an unspendable address, and this reduces the circulating supply of the token. It's also possible that in the future, when the community decide to reallocate these tokens through a Filecoin improvement proposal, but that will be up to the community as well. Juan, do you have anything yet, or?
Yeah, I would say, yeah, no, I think we should count on all these tokens being burned forever and in the long term. It is possible, like anything in the protocol, it is possible that in the long term, people decide, the community decides that they should be used, but we expect that that won't be the case, that they will just be burned forever. And so I think at least kind of in the next 3 to 5 years and so on, that we should assume that that's the case. That, however, again, like, none of us control the network, right? As soon as we release a network, it's a governance process that is network oriented. And so if the community decides to do something, like, that's the community's decision. So none of what ZX and I say today, you can't count on any of it, because we ourselves, once the network is in the mainnet, like, it's the community's decision. So what the community ends up deciding is what's going to happen.
Yep. And where we'll find it.
Could you refresh your browser? I think I added another question in there that came in.
Let's see. I have to exit and refresh.
Yeah, right. So what uptime and SLAs are expected for miners? And so SLAs are, service level agreements. What kind of uptime is required? So this is really important, and it's a really important question that comes a lot. So storage miners really require 24/7 operation. We want to operate. They have to operate all the time. So and this kind of operation involves consensus, storing data, proving data, accepting deals, serving data, and more. Now, this is less strong for smaller miners. The larger the miner, the more important this is. So you can think of smaller miners as being able to be a little bit less reliable. Larger miners have to be much more reliable, especially for consensus. Consensus is the really important one. Now, you should consider that being a storage miner on Filecoin is running and participating in a cloud storage service. That means it should be in operation all the time. We want to achieve reliability to be able to compete with other clouds. And so think about 5 or 6 nines of reliability. That's really hard to do. We won't be there at the beginning, but we can get there over time. So over time, we can hit that. So imagine at the beginning, we start with 1 9 of reliability, then 2, then 3, and so on. But this really requires kind of the 24/7 operation of storage miners. Now, this is especially critical for consensus power. So if you're participating in one of the top 20 or top 30 miners, that means you have a significant fraction of the consensus power. That means that you need to participate actively and be ready to take action if the chain starts doing something problematic. Blockchains are living systems that are under attack all the time. So you can think of Bitcoin and Ethereum and many other chains as being under attack by a lot of participants all the time. So think of all the different hacks that people have tried, or DOS attacks and so on. So this means that storage miners that have a significant amount of power need to be able to respond to emergencies. So problems can and will happen, and miners need to be alert to fix those problems. So this means larger facilities and larger operations will have many people involved, and there'll be kind of on-call rotations. It's really important that certain kinds of attacks on the network require responses in very short time, meaning 1 or 2 hours. We've seen responses in Bitcoin and Ethereum that require that kind of speedy response. It's very rare. We hope that this is a very rare thing, but we do need a significant fraction of the consensus power being able to interact and operate at that speed. So we're working to provide some channels for communication for storage miners that represent a large amount of the power, and so on, to be able to coordinate in the event of these kinds of problems. And so we'll have more to say there. But it's really important that storage miners really consider the uptime guarantees that are required to satisfy the economic requirements of the network. If we can't provide that as a whole network, then slashing happens, then the network stops, and the block rewards aren't getting released. All kinds of economic activity doesn't happen. This is really critical of the network. The network continues.
Right, and just to remind ourselves again, I think we said that as well. I think currently we don't assume that in the penalty rules is a much more reasonable and relaxed storage reliability requirement. Next, when will final parameters be released? So I think it should be clear by now. There will be, I mean, there isn't really a final parameter. There are no really a final parameters. There are no final parameters since the system continuously evolve and improvement can always be made and new features and understanding will emerge. And this is very interesting in terms of the economic problem that we're dealing with. We are basically an evolutionary economic system. But we should be making the mainnet a parameter recommendation available pretty soon. This is a question. The question is specific to the gas fee calculation. So the question was, I believe, is about, do we consider charging different base fee based on different message types? Actually, we did. We actually recommended counting based on the different message types because some of the messages like proof commit or it's a simple transaction, they might have different economic meaning to the network. But there are other constraints that we have to deal with here. So this would be considered as a Filecoin improvement proposal. And just want to make a note, the current model actually charges different fees based on the message type because it's based on the burn fee is based on the gas usage, and gas usage varies across different message types. And just want to make sure we're on the same page on the goal and constraint. So there should be a network-wide base fee that is burned for the usage of gas as messages consume on-chain resources. And it makes sense to pay to the network. Otherwise, we create a bunch of other incentive issues that we mentioned below, such as the externality associated with a pretty expensive message that, let's say, the miner can potentially put in for free, or some denial of service attack that we also observed during testnet. And the message sender should send a priority fee directly to the miner, untethered to the gas usage, and they should maintain the same incentive for miner in terms of packing messages into a block, and that should also make it easier to reason about the incentive. Thanks.
Yeah, I think I would add here that that we've seen just in the space race so far a lot of fees burnt, and so we're working on the parameters there to make sure that less is burned.
And there are also other factors that go into why that is the case, but we're also looking into that.
Yeah, a lot of that is just software, like having just not immediately sending and waiting until the chain is less congested, right, and so on.
Yeah. Exactly, which I kept saying is actually a good learning point for all of us, that it's not about getting your chain in ASAP. Getting a message in ASAP is important, but it's not zero sum, right? Like people keep talking about tragedy of the commons because we learn a lot about that in economic textbook, but at the same time, there are also amazing things that common collectively do together that's beyond just either state or market. And I think this is the scenario that we are in. And it's actually very exciting as a new frontier in economics. I think this should be the last question on the slide. How is participation incentivized in Filecoin? And is there a tension between client desire for low price storage and miners' interest in profit? So very important question, but tying back to our mental model as Filecoin as a storage economy where we all come together to produce storage-related goods and services, will benefit when the economy thrives and produces value or utility. And we consider a country with currency and this export industry, we have raw materials coming in, and then we are converting that into goods and services to be exported. And whether this value really get translated into the exchange rate with other currency pairs, with other currency, it's really based on the supply and demand on the market itself. But something that we do know in terms of fundamental forces is generating tokens very quickly when there's little utility on the network might lead to depreciation. And as we mentioned earlier in Juan's presentation for this S-curve, miner revenue in the long run should be driven by the storage due payments. And these deals are initially heavily subsidized by the network with the goal that we actually subsidize reliable and useful storage such that this actual organic paying deals will come in the future. I believe that's all here. And I think let me just exit my screen share.
Can you pass to me for a moment?
Yeah, of course.
Just want to, one really big important disclaimer this stuff is subject to change. Everything here is a preview. Like, we're very close already. We think a lot of the parameters here are really set, but just don't make a lot of decisions. Just this is a preview. This is work in development, and so on. So really strong disclaimer on the information.
Yep, and as I said, I think we're the frontier of networks, social system, economic system, technical network system. And I think it requires all of us to come together to pool our knowledge and experience and resources to build something valuable and meaningful together.
Yeah, we're really excited about where this is headed. We're really excited about the entire network. We're looking at the space race numbers, and it's amazing that we're hitting this much storage. Let's look at it right now. We're at 89 petabytes just in the amount of time that we've talked. Another petabyte has been added to the network. This is amazing. We're about to hit 90. That's a really huge amount of storage. I can't wait to see how we can use that to provide really valuable storage for a lot of useful clients and useful data. That's kind of like an important next challenge for a lot of the community. And yeah, we're getting super close to the mainnet launch. We just need to get through the space race, and use all of the learnings that we're getting from space race to make improvements, and find good ways of dealing with this kind of network initialization question, and we're almost there. So it's really exciting to be here with everybody. The entire team is super stoked and excited about where we are. It's been, for many of us, it's been many years of work to reach this moment. So we've been working super hard for many years to be here. We're super excited about the economy that we're building together. We're super excited for your participation in providing this really new kind of service, and new kind of utility, and new kind of economic structure. We hope that the conversation today has been really useful. We saw there's a lot of questions on the chat, but we've kind of been going for a couple of hours now. So we'll probably take most of the, we'll grab a lot of the questions there from chat and keep them for, we tried to answer a lot of them as we went. But we if there are a few more, definitely go to Slack and ask them there, and we'll make sure to come back to some of this later on. We might, ZX, I don't know if you have a bit more time to take a few more questions, but maybe if we take maybe 5 questions from chat, and then we can call it a day. So let's see. Question. I'm gonna go in maybe I'll go in order from the top down, since people have been asked questions for a long time before. Yeah, I think questions around, hey, like with the lockups be 180 days. I think this was a question about the vesting and so on.
Right. I think we're still evaluating some of this. We will have updates on the mainnet recommendation pretty soon.
Yeah, I'm just scrolling through a lot of questions that we did answer.
Yeah, I think we tried to answer some of them as we went to. Let's see.
Yeah, I think, and then kind of like the big question is like, hey, how's the mainnet timing and so on? We feel really good about it. We feel the whole network is working really well. We see this amount of storage online. Stay tuned for more updates on this, but yeah, we're looking to be in really good shape. How after mainnet launch should the Discover data need to be sealed and available? Great, that's a great question. So I'll defer to the Filecoin Discover folks. I think we can ask that on Slack. That data is also waiting for the verifiers to be online to be able to hand out verified deals. So we're working on that right now to line up some good verifiers initially. We think it's really important that the Discover data is not the only verified data. So we want to make sure that when the discovered data comes online, it also comes online with other verified data that's not the discovered data. And so we're just working right now to line up a few more folks adding data. If you can find some extremely useful sources of data and storage in various different regions of the world, especially in Asia Pacific regions or in Europe, would love to hear from your suggestions, especially scientific data. So if you have any groups that are trying to store a lot of really useful, valuable scientific data, reach out to me on Slack, and I'll incorporate those into some of the potential first verifiers. Great, thank you very much. We're super excited about this. Thanks for joining us for so long. Have a great night. Thank you so much, ZX, for your awesome explanation. I'm sure a lot of people got your are super thankful for your answer. Keep going with the space race, everyone. There's a lot of stuff going on. We're so blown away and so excited about reaching 100 petabytes that we added another goal after 100. So there's another 500,000 Filecoin up for grabs in the global to reach the 200 mark. So keep going. We want to hit as much storage as we can, and remember that we're trying to find a good way to use all of the storage that you're stealing. So again, we can't guarantee it yet, but we're finding good ways for that. Good luck and good luck with the competition, and see you all soon. Thanks so much.